To this video on manufacturing processes. This is a continuation of process analysis that we started last week. So in this video, we'll specifically talk about manufacturing processes and differentiate them from service processes. Right. So okay. So what are manufacturing processes? So manufacturing processes are processes that are used to make tangible goods, goods that you can touch and feel. In a very high level, they are divided into three steps. You source the parts, you source your raw materials, you make the part, and then you sell it to your customer or you deliver the part. Right now, there are this is a very high level view, but there are obviously many different stages within this, right? So a few things to know about manufacturing processes of jargon, you might say. One is lead time. Lead time is the time needed to respond to a customer order. So once a customer places an order, when do they receive their order? That's the lead time. So if you're going to, say, a grocery store to buy salt, there is no lead time. You want salt, you go there, you buy the salt immediately. But let's say that you want to buy a special car with a certain trim and some other add-ons, then that might not be available in the lot right away. It might take a few days, and that's the lead time. Sometimes you might have to order, say, let's say you're Macy's and you want to order t-shirts that are made in China. Lead time can be months and sometimes even a year. So lead time can be any number from zero to as long as you can imagine. So, but that's a concept of lead time. Now, the other important point to remember here is the customer order decoupling point. So that's another important thing to remember. So customer order decoupling point essentially tells you exactly where is the inventory position so that the entities on different sides of the supply chain operate independently. So if you remember from what we talked about with process analysis is if you have in different stages in process, if you have an inventory between two stages, then you're decoupling the two stages, right? Now in manufacturing processes, when you look at the whole supply chain, so you have to decide where the customer order decoupling point is, and that decides what kind of process you have, right? We will talk a little bit about lean manufacturing in a different video, not in this one, right? So based on where the customer order decoupling point is, you have different types of firms, right? So the first type of firm is a make to stock firm, which serves customers finished goods inventory. So this is the salt example that I gave. So you have finished goods, you go to a store, you buy it and you pick it up. Or it could even be something, let's say, that's already manufactured, but you're buying from, say, Amazon. Let's say you're buying a book on Amazon, it is a finished product. So it is make to stock, which means that the product has been made and it is in stock and you're buying straight from the stock, right? So uh, that's a make to stock system. And there, the customer order decoupling point is all the way at the end. It is at the deliver stage, almost at the end of the make stage, close to the deliver stage, right? Now, the second type of firm that you have is an assembled to order firm. This is where you combine a number of pre-assembled modules to meet a customer's specifications. The best example that I can think of for this is the car example that I gave, where you have a finished car, but you might want extra add-ons to the car, or you could think of buying a laptop. So when you're buying a laptop, you can choose the memory that you want, the type of screen that you want, how large the laptop is, what kind of features it has. So all of these things have already been manufactured. All the different parts have already been manufactured, but they will be assembled once you place an order for your laptop. So that's assembled to order. There, the customer order decoupling point is slightly ahead. So it is in the middle of the make process. So part of the making process is done, the rest of the making process has not been completed. So that's the assembly portion that has not been completed, right? And then you have make to order, where none most of the item has not been manufactured. And the best example for this is, say, custom furniture. You want a specific kind of couch, or you want a specific kind of table, or you want a specific kind of dresser. You go and you place an order for it, either from a catalog that a company has, or you might hire a carpenter to have them make it for you. So it is make to order, right? So until the order is placed, you don't know exactly where what the order is going to be. So you cannot do any of the manufacturing. So if you notice the customer order decoupling point, it is pretty early in the make process. Sometimes right at the beginning of the make process, the only thing you've done is you've sourced your raw materials. So let's say with the furniture example, you've sourced the wood, you've sourced the paint, you've sourced all the different things, nuts and bolts that go into making this furniture of a certain kind. The only thing you don't know is exactly what the feature or what the configuration of the furniture is going to be, right? So that's the example of a make to order system. And finally, you have engineer to order. So engineer to order where even the sourcing has not been done completely, right? So you're engineering everything specifically for a particular thing. You're, let's say when NASA makes a shuttle, right? So when NASA manufactures a new shuttle, even the nuts and bolts are made specifically for that particular shuttle because it has to withstand a uh, lot of heat and a lot of pressure, and it has radiation in space and so on. So everything has to be engineered to order. So there, the customer order decoupling point is part of the sourcing process. You're not even in the making process just yet, right? So the customer order decoupling point goes back. As it goes back, the customer becomes more and more involved in the manufacturing process itself. In engineer to order, the customer tells you exactly what the manufacturer is going to be, and in make to stock, the customer is just buying a fully manufactured good. So there are different types of manufacturing types of firms that you can have, right? And that's the idea. So you have make to stock, assemble to order, make to order, or engineer to order, right? Now, so this is one way to classify the different types of firms that you have making this. But there's another way of classifying the way manufacturing itself is done, right? So it's good to understand the different configurations of manufacturing processes that you have. So when companies manufacture something, the way they organize their manufacturing processes are different. Manufacture can be different, right? So you have everything from a project layout all the way to a continuous process. So project layout is you're making a one-off item. So going back to the example of a shuttle, let's say that there is you're putting a satellite into space. So that's a unique satellite. There might be some commonality with other satellite, but you're making specifically for a particular reason, and it is engineered to build. And so once you build it, you're not going to use those processes again. So all the product will remain in a fixed location, and everybody from different places comes in and manufactures it. Another good example of this is, say, manufacturing big aeroplanes. So each of these airplanes is considered a project, and the layout is such that the item stays in a single place and all the different processes happen around the item. So if you have to weld something, or you have to, you know, join something, or you have to mold something, all of those things happen around the manufacture of the plane or the space shuttle itself, right? Now, the next type of way in which manufacturing processes are organized is a job shop, right? So this is where you have a shop where you cannot manufacture a lot of items, but you're manufacturing specialty items. So this is a manufacturing shop where, let's say that all the milling machines will be in one corner, all the welding will happen in a particular corner, all the joining happens in a different corner, assembly happens in a different corner. So all similar machines are organized together. So if you go to a job shop, you'll notice that there'll be a milling department, there'll be a assembly department, there'll be a woodworking department, there'll be a um, painting department, and so on. So there are different departments, and in different places the manufacturing is organized that way. So any part that comes in probably has to go to all the different departments. So it probably starts with the milling department, then goes to the assembly department, then the painting department, or so on. So depending upon how the product is manufactured, it moves through these different job shops, different parts of the job shop, right? Now, the one thing about this I want you to notice is that as you go from the project layout to continuous process, the number of items that you can manufacture, the output of the process is going up. So the project layout, you're you're doing one or maybe two or maybe three of these items. But with the work center layout, you can do more. You can make a few more of these items. Now, the next type of manufacturing way of organizing manufacturing processes is manufacturing cell. So manufacturing cell is a dedicated area for making a particular process. So this is where um, oops, I'm sorry. So this is where all the machines required to manufacture a particular process are in a particular place. So there's a dedicated area to make a particular product. So let's say that you need one milling machine, two molding machines, and a lathe machine, and let's say a finishing machine and a painting machine to make a particular product. All of those machines are organized into a manufacturing cell, and then all the manufacture for that particular product happens there. But you can have many different manufacturing cells throughout the job floor, and you make different kinds of products there, and that way you can make more products than with the job shop, because in a job shop every item has to move from location to location to location, so all the transit takes time. You need to have a lot of inventory buffers. But with the manufacturing cell, you can have everything can happen within a single area, and so the productivity will be the number of items that you can make will be higher, right? Finally, you have assembly line and continuous process. So assembly line is the way cars are manufactured. Obviously, that's the classic example. So the raw materials go in, and there are structured processes that happen one after the other, and then a final product comes out at the end. Now, there is another level after assembly line, which is continuous process. So processes where start to finish there's hardly any stop. So continuous process. So liquids are a good example. So uh, if you have a refinery where crude oil is drilled, so crude oil is drilled, then it is refined, and all of those things have to happen quickly, one after the other, because liquid is literally flowing through pipes or flowing through your process, so everything has to happen very quickly. So you have a continuous process. Now, project layout, you can make one or two items. With continuous process, you can make millions, say hundreds of thousands of gallons per day. The difference is, with project layout, you have a lot more flexibility. If a particular let's say that you're making a plane for a particular airline, they want it painted a certain way, or they did not want, let's say, instead of having four seats in the middle, they just want three seats in the middle. They want a 3-3-3 configuration instead of a 3-4-3. You can do that because each plane is unique, right? But with the continuous process, you do not have any flexibility at all. So as you go through this, you'll notice that the number of items that you can make, the output of the process increases, but flexibility in the process will reduce. And that is what is shown in this picture, right? So product standardization, so highly standard products, that's when you make continuous processes, and product volume will also be high. But if you have one of a kind products, then the process will be inefficient because you have to make them one at a time. But that is when you need a project layout, right? And that's the idea. This is the famous product process matrix, and every product that is manufactured will fall into um, one of these cells, right? So now, how do you decide which type of layout or which type of machine to use? So you can do a simple break-even analysis to figure that out. So it's a standard approach. I'm sure you've looked at break-even analysis in many different settings. Here is an example of break-even analysis in this particular setting. So let's take an example. So you have these options that you can do. You can either purchase a unit for $200 per unit. So you're selling the item for $300, I think. Yeah. So you can purchase the item for $200 per unit, or you can make it on a lathe. If you make it on a lathe, it will be $75 per unit because you need a lot more labor time for that. But if you get a machining center, it will be $15 per unit. Now, if you purchase, there are no fixed costs. You're just buying it from outside, it's $200 per unit. But if you buy a lathe, then there are $80,000 in fixed costs. But if you have to get a machining center, the fixed costs are $200,000. There's a fixed cost of $200,000. So the question is, which of these three options should you do? Should you purchase? Should you make it on a lathe, or should you make it on a machining center. That obviously depends upon how many units you're making, right? So that's where the break-even analysis comes in. So if you look at the total cost for the purchase is whatever your demand is. So we'll assume that whatever demand is, we'll be able to supply everything that is demanded. Then the total cost will be just $200 times demand. That's how many units that you're selling, and this is the cost because you have to buy it from the outside. Now, when you're producing with the lathe, so 75 times demand, that's your variable cost, plus a $80,000 fixed cost. And when you're producing with a machining center, you have $200,000 fixed cost and $15 times demand, whatever your demand is. That's how much your cost is going to be. So you can write this as, say, cost is Y. So this will be Y is 200x. This will be Y is 80,000 plus 75x. And this will be Y is 200,000 plus 15x. So you can plot the straight lines and then figure out where they meet, or you can just set these equal to each other to calculate where the break-even point is. So if you plot them together, you'll notice that, so forget about the revenue piece. So this is the option of just buying. So 200 items. So you just buy it straight up. So it's just how many units you have. This you're going to pay $200 times the number of units that you make. So that's the line there. Right. I'm sorry. So this is the line for buying for $200. That's not. I'm sorry. That's not it. So this is the line for buying at $200 per unit. Now this is the line for making it on a lathe. So that's the line for making it on a lathe, and this is the line for making it using the machining center, right? So if the number of units, if the demand that you have is very low, then the best option is to buy, because you notice that buying, this is the straight line for buying, is lower than the other two options. I don't know why they have this red line. So this red line is confusing. So this is lower than these two options. So this is the lathe option and this is the machine center option. So buying is better than these two options, but there will come a time when the lathe option becomes better than the buying option. So this is the point where the lathe option becomes better than the buying option, and slowly as the number of units increase, the cost will increase, and then there will come a point where the machining center becomes better than the lathe option. So the point A is where so first it will be the buying option up to point B. So point B, so this is the number of units at which the lathe becomes a better option, and then after a while this is the number of units at which the machining center becomes a better option. So this green that you see, so first it's buy, then it's make on a lathe, and then it's a machine center. So we need to find this break-even point and we need to find this break-even point, right? So let's do point A first. So when does the machine center buying the machine center become better than making it on a lathe? So if you set those two values equal to each other, because the lines are intersecting, that the values are equal, then you can solve for demand, and demand is 2000. So when demand is exactly equal to 2000, then both the machine center and lathe have the exact same cost. But once demand is even slightly more than 2000, then machine center is better. If demand is less than 2000, lathe is better, right? And then a point B, so this is where you go from buying to the lathe. So if you set that equal to each other and you calculate, demand is 640. So once demand crosses 640, buying it from outside, it doesn't make sense. So if your demand is less than 640, so let's say that you expect demand is going to be like 200, 300 or 400 or something like that, then it doesn't make sense for you to manufacture yourself, just acquire it from outside and sell it. But once demand crosses 640, it makes sense for you to use the lathe till demand reaches 2000, after which it makes sense for you to buy the machine center. So it's not as if you're first going to buy it from outside, then buy a lathe, then buy a machining center. That's not what's going to happen. You project out, let's say 2 or 3 years into the future, and then figure out what your demand is going to be, and then you make a decision. So at this point, am I going to be buying for the next 3 years, or am I going to acquire a lathe or to work for the next 3 years, or am I going to buy the machining center? It all comes down to what you expect your demand is going to be. So yeah. So this is a simple example of a break-even point. So this video has already gone on for too long. What I'll do is I'll end it right here. And then in the next, we'll look at an example of process analysis in the manufacturing setting, right? I'll see you in the next video. Take care.